Okay, as usual, I will start with the course outline. All right, you will notice that there are two different codes. Okay, one is the old code and one is the new code. Now the difference is that you will notice the old code, right, start with 4, EE417. That means this subject only offer in year 4. But for the new code, BEE3073 is offered in year 3. Now, why we are doing that? Because in the past, we found that, right, year 4 is a bit late already for the student to really study power electronics because they have final year projects and a lot of things, all right? So we decided to move it to year 3. So better get you all better prepared, okay, for your final year. So we are going to have the normal 5 CLO, all right? And these 5 CLO are clearly divided into 5 different chapters. And these 5 different chapters, I already upload the lecture note in CN. You can see there are 5 chapters. Okay, there are 5 chapters. And of course, you will study the device. You will study the 4 important converters, okay, for the power electronics. And we basically cover 2 PLO, the problem analysis, okay, and design and development of solution. The assessment is pretty straightforward. You have 1 midterm, 20 marks, 1 group assignment, 30 marks, and 1 your final exam, 50 marks. Okay, so basically there are 3 assessments. Okay, so like I said, there are only 5 chapters here. Okay, 5 chapters. The first chapter, we are going to talk about the power electronic semiconductor devices, such as the MOSFET transistor, the diode, and so forth. The component that require to build a power converter. And then we will move on into the 4 types of converter, the 4 categories that I will say, which will cover the entire power electronics. The first one is AC to AC converter. The second one is DC to DC converter. Third one is DC to AC and AC to DC. That's all. Okay. So these are the 4 pillars of power electronics. Now the good thing is that it doesn't mean that you must know AC converter, only you know the rest. The beauty of power electronics, right? You can start with any one of them. Okay, and then of course, it depends on you which one you want to focus on or you want to master. And you can see that, in fact, I will spend roughly, I think, around 2 to 3 weeks, right, per chapter. Okay, plus minus. Okay, so the rest is just the hour thing. Okay, pretty straightforward. And that's the PLO. So any questions? Okay, I think that is very straightforward, right? Okay. Now we move on, teaching plan. Okay, like I said, I will spend like 2 to 3 weeks time for all these different converters. Like I say, we can never follow exactly the teaching plan. Okay. Of course, midterm will be at week 8 or 9. It depends on the progress of the class. And then the last week, okay, basically there is no more class. The last week is only for you all to do your assignment, presentation, and demo. Okay, you need to show me a demonstration. Okay, on this. I'm still considering whether want you guys to do hardware or not. Okay, got pro and cons. If you can do hardware, beautiful. You are no longer talking on paper, right? You can draw the circuit, you can make it work. Okay, but now the challenge is that there are still some students online. So I don't know how. In the past, where they are physical, I always require a hardware. All right. Maybe I will make it optional. Let's see. Okay. Because it may be not fair for those who are not in the country. They cannot get a pass and so forth, and grouping problem. But to me, it's a bit waste if you don't, because electronics or electrical on paper and building the hardware is totally different story. You will find a lot of tricks that the textbook will never tell you. Until you do it yourself, you'll find that, oh, this is required or that is required. Even for simulation, right? You can simulate so perfectly, but when you come to hardware, you will see some either limitation or some phenomenon that the simulation will not take into account. Okay, for example, heating problem. Even though I will teach you how the heating thing, okay, but they are still like overheating issue. Okay. So you all log in already, right? Log in and log out. Remember to log in and log out for those in the physical class, so that I can get your attendance. Okay, don't tell me you come, and then I forget to all this. We also try not to use the old ways or paper thing already lah. For those online, no issue. Okay, today I'm going to go through these introductions. Okay. Oh, how come something like that? Toggle. Okay, as for today, I'm going to give you a brief introduction, okay, of this power electronics. Okay, first thing first. How important is power electronics for electrical engineer? I will need to say, especially in Malaysia. Okay, for those international students, I think you all I have no effect for this. All right, so it shouldn't be an issue, but make sure when you back to your country, right? Your country should have the engineering board. Okay, please check with them. You know, like say, oh, is this topic important or not? Okay, later I will tell you the story. Now, you will notice that there is a link. Okay, you can click the link, all right, and then you can actually visit the Malaysia Board of Engineer website. Okay. Oh my God, how do I end this? Okay, I think I better use this. Okay. Now, if I just, you know, you can just cut and paste the link. And again, for mechatronics student, right, it shouldn't affect you. Okay, it shouldn't affect you. International student, just make sure you check back in your country. For Malaysian student who doing E&E, this is a big problem. Okay, now the thing is that you will notice that, right, you are taking E&E, electrical and electronic engineering. Once you graduate, you register to BEM, right? Very straightforward. And make sure that you register yourself as electrical engineering. There are three choices: electrical engineering, electronic engineering, electrical and electronic engineering. Please don't be greedy to tick the electrical and electronic engineering. Okay, the reason is this is under the BEM regulation. Only electrical engineering, if you are registered as electrical, you can do all sort of electrical engineering work, including electronics, including submission to government, including your IR certification. All right? But if you go and, you know, tangan itchy, go and tick the E&E, I wish you good luck. That means if you other than that, let's say electronic, you can do electronic, but cannot do electrical work. So it's a disadvantage, right? It's a very, very clear disadvantage. All right? So make sure you register electrical. And also, not every university program can register as electrical. And of course, don't worry, UCSI degree are recognized. You can register as electrical. Okay, that is for sure. Not to worry. And then, now, how they are going to decide that, because when we submit our form, right, our degree is E&E, right? So how they're going to decide you are eligible to register as electrical or electronic? It's not depend on your face already, you know. Okay. Now, what they are looking at is they are looking at all these subjects. These are the subject lists. Okay. Now, you must have machine and drive. You all study electrical machine, right? Okay, that one check. Electrical machine. You all study, right? Check. Drive or power electronic. Check. EM theory. EMT 1, right? At least you must have one. You don't have two, never mind. You must have at least one. Circuit theory. Okay. Electrical power system. In our case, we call power system. Okay. High voltage. We got energy conversion and high voltage. And they have another called electrical engineering system, which is the electrical power. So these are the lists, okay, that if your transcript have this subject, that means you are eligible, okay, to register as electrical engineer. So in other words, this, you see, you study more than, I think, 30, 40 subjects, right? Okay, but you see, BEM only choose this few. So it's indirectly telling us that how important is this. because there are really many cases of students, especially in some other, even overseas university, because they have electives. And during their study overseas, I mean, you know, they don't tell you what happened in Malaysia, right? So they will just simply take whatever subject they think they are interested, or they follow their friends. Okay, of course, when they end up coming back to Malaysia, they cannot register as electrical. All right, so that is the what we call this the issue that you all have to know lah. Okay, it's a very painful lesson to learn because I'm one of them. Okay, now you don't think I got IR very short? Oh, Dr. IR, I tell you, my IR is useless. If you compare to, let's say, like if I want to certify design, I cannot certify even a wire 200 to connect to a light bulb. So simple, right? Any joker can do, right? I cannot certify. Simply because I was registered as electronic. What the toot, right? Really, what the toot? So, very painful lesson. And then, is there a way to change? Or you need to endure more painful? First, you need to disqualify yourself as IR. Okay? That means you cancel your own IR, and then you start your experience again from zero. That means I need to wait for another 3 years, okay, and go through the exam again. And these 3 years, I must do some project related to electrical in order to do that. Painful, right? So I'm not going to do that anymore. Because the IRCN examination is, you know, it really based on your experience. The moment you age like myself, I think no need already. But you're still young. What happened to me is that, firstly, no one has told me about this, including my university. I was studying in UK. Obviously, they don't tell me this. They just say, oh, we UK got chartered engineer, go for it. Then we go for it lah. Then shit. You know what subject I'm missing here? EMT. 1. Okay? So they don't care you got circuit theory 1, 2, 3, 4, 5 until 10. You just mean one subject, that's it, man. That's it. Sorry. You know, so I hope to let you all know that do not repeat my mistake. Okay, because you're going to pay a great price for it. And it's not about the knowledge you know, it's about the qualification you have. So like I say, it's a country policy, I would say. But in UK, it's different. UK chartered engineer, I'm also a chartered engineer. But they look things different. In UK, the Western country, they will appreciate what you know. It's not what certificate you have. You know electrical, you can sign with the chartered engineer. That's the difference. I don't blame, you know, anyone or any country policy. They have their reason to do that. They have their reason, okay? So be aware of this kind of thing. And of course, why I'm showing this today, okay, you will say that, sir, if I can get my degree means I already passed Power E. What's so important, right? Okay, of course, this is, I would say it's unwritten rule. I would just say, make sure you don't get sub law. Right? You know, the officer can say, oh, ini sub, not count. Shit, right? Electrical only lah. Mecha you can sub 10 times, never mind. But electrical, please. Okay, that is what I can tell you guys and girls now. Okay, So you can see this is already on their official website. You cannot go to there and say, oh, sorry, no one tell me, I don't know. They will say, sorry, you don't know, it's a problem. You know, I mean, this is a what we call engineering act. Okay, go through the parliament is part of the act already, you cannot change. It's a rules, it's a law, okay? So try not to define the law, okay, unless you're a lawyer. All right, so it's written here very clearly, all right, for those Malaysian students who are taking E&E. So any questions? Of course, like I say, for international student, it depends on which country you come from. They will recognize certain what we call this professional engineer. Okay, for example, if you take chartered engineer, right, it is recognized in many countries. It recognized basically most Commonwealth country, okay, like Australia, India, of course UK themselves, Europe. So it is widely acceptable. And it doesn't bound by this, are you electrical? Are you electronic? This kind of thing, okay? So, and it's important that, especially if you work with the MNC company, if the company say, okay, we got like ABB in Malaysia, like ABB, right? It's a Europe company. They have project over there, and they may send you over there to do project. But what if you say you don't have CN? They will say you wait law. And then the newcomer just joined 1 month, got CN, he can fly. Okay, so get yourself, certified as soon as possible. And the good thing with the CNs is, you see, with the CNs, right, if you go Hong Kong, you can, what we call, just like the bonus link redeem reward, you can redeem the Hong Kong also use IR as an engineer. You don't need to go through exam, everything. You just say, I got CN, give me IR. They will say, please fill up the form and pay money. Just like that, exchange. And then another one is European engineer. Cover the entire Europe. You go UK, you take the CN, again, fill in the form, pay the money, you get the title of European engineer. I believe you all should know that mechatronics, our deputy dean, right, Dr. Lim, and our dean, both of them are European engineer. Just redeem like bonus link. And of course, how to achieve that? You need a mentor who are willing to guide you through the process. All right. Okay. Let's see. It is someone. Wait. You see, the problem right now is that I'm too focused on the physical now. Online one talk to me, I also don't know. Let me check anyone talk to me. Oh, could you please add my friend? Alamak. Hey, you all use the code, can give your friend the team code that I posted in this IIS. With that code, he can join the class. Ryan Muhammad, you hear me?
Yes, sir. Yes, sir.
Yeah, you gave him the code, okay?
Okay, thank you.
Okay, up to this point, any question for the first slide? Okay, recommended book. I don't really use textbook or follow textbook to teach. As you can see, the first book is 400 to 500 pages. Okay, and book is for you to read, right? I'm here to lecture, right? So basically what I do is that I actually, prepare all the slides, okay? That will consist of all this information you require to know about Power E. Okay, and if you would like to know more, okay, then you can always go to the textbook. So these are the 4 textbooks that I highly recommended, okay, for you all to reference. Now the problem with textbook is that the first one, okay, and the second one also written in, I think the fourth one, yeah, all written in US. The example, everything is US. 60 Hertz, 110, application also US. It's very difficult, okay? So I try to localize it, okay? To localize it to Malaysia scenario, of course, still give you a global view of what are the potential application, all right? So these are the 4 textbooks, which I think is good enough, okay, for you to reference, okay, into more detail. Okay, now we come to power converter. Like I said, the 4 pillars of power electronic is power converter. Okay, it convert or transfer electrical power or energy from the source, okay, to the load in a controlled manner. Okay, so meaning that, okay, you always have one input and one output. Okay, input is your source, output is your load. And then you will see that, like I said, there are only 4 types category. AC converter, this is the block. That means it converts AC to AC. Okay, and it sounds so stupid, right? You already AC, why you still want AC, right? Of course, there are reasons behind lah. So when we come to this chapter, I will talk more about it. Okay, and AC to DC, we know that, oh, okay, you come in AC, your output is DC, okay? That is reason, the reason is good enough, right? You convert it. And similarly, we also have DC to DC. It also sounds stupid, like, okay, I come in DC already, I know why the point of conversion. And the last one is DC to AC. Now, the easiest way to remember this is that you have to know that electricity consists of AC and DC. And you just combine them, you end up with 4, right? So this is how you can remember the 4 types. And this is the typical symbol, okay? You can see that there's always a square box, okay, cut half diagonally. And then this symbol represents AC, okay, AC. When you look at this, you know it's AC. Okay, and this one is DC. Okay, or some people or some other textbook, they can straight away write AC here or AC here. It's also okay. No fixed rule. Okay, but this is how it should look like. Okay, now let's see what are the typical application of this converter. Now, AC converter. The most common one is this, the light dimmer in your house. You know, when you can turn your light bulb brighter or dimmer. So it's AC to AC. Because you come in is AC, you go out also AC, right? Okay. And of course, it can be as high as transmission line. Okay, and this is what we are talking about, like 500 kilowatt, 450 kilowatt, okay, of transmission. All these transmission line we see up there, right? Okay, there has certain way to control the power flow. Okay, there must be a way to control the power flow. And then the other one, AC to DC. Okay, this type of, the Dyson hair dryer, okay, is running using DC motor. Of course, a normal dryer will be running an AC motor. Okay, so in this case, you need the AC to DC, right, to power this up. And then the other one is DC converter. Now, DC converter, just like a power bank, okay, it's DC to DC. Okay. And we have another one is DC to AC. This type of motor, okay, or cooling fan, okay, we call it brushless, the one used at the computer one, okay, brushless DC motor, so-called. In fact, you are converting a DC to AC. And of course, one of the greatest invention, the badminton racket for mosquito, okay, zapper, is actually also a DC to AC converter inside. So this is just a few of them. Of course, there are so many, Power electronics is actually, everywhere, I would say. Now, you see, these are the 4 building blocks. It's just like a Lego building blocks. If you use it alone, it is something. But when you combine them together, right, it becomes something else. Okay? So when you combine both together, when the coming in is AC to DC, and then DC to DC, what you have is your phone charger. Your phone charger, okay, it consists of 2 converters inside. The AC to DC first, and then DC to DC to regulate. Okay, and of course, this one is an LED light bulb. LED light bulb also, when you plug on, is AC coming in, right? AC to DC, but the DC is too high, so you need regulate. Okay, so you need another DC to DC converter. And also the EV electric car charger, all right, is also AC to DC and DC to DC to step up the wattage, okay, so that you can charge your car battery. Because your car battery is around 400 and above, 600, 800. But our AC plug is only 230, right? How to charge? So it convert to DC first, and then DC to DC to step up the wattage. And when you combine something like that, DC to DC, and then DC to AC, that is the solar inverter. Okay, solar inverter or your electric scooter to power the motor. Okay, nowadays all these electric scooter, right, they are using the brushless DC motor, which is very, very powerful in terms of torque. And then we also have this AC to DC, DC to AC. You will have this what we call the variable speed drive to control industrial motor. Okay, or our new aircon, so-called inverter aircon. All right, now in the old days, right, our aircon is just AC to AC, that's all, right? Power the compressor. Okay, but it is not very efficient. So nowadays you will find that the aircon say, oh, I'm an inverter aircon, much more efficient, save energy, right? So inside what they did is that instead of just using one AC, they just put AC-DC, DC-AC, okay? Then they can control the compressor better, okay, and more efficient. And of course, because you are paying for a 2 converter, right, it will be slightly expensive than the ordinary AC, okay? But when you understand their concept, is actually what we call, you will feel that it is worth it for paying that amount of money. Okay, now if we connect them 3 in a row, it's unlimited. You can connect that up, down, however, depend on your innovation. That is how the product keep on coming in. Okay, like this inverter, the car battery inverter, okay, is DC to AC, AC to DC again, and DC to AC. Okay, of course, there is a reason for every steps, all right? And for EV, okay, when you charge is AC to DC, DC to DC, okay, then this is bi-directional. Now, all the while I'm showing you guys, right, is one direction only, from the source to the load, right? Unidirectional. Converter can be bi-directional, meaning that it can go in both directions, okay? And this is what we call bi-directional converter. So it's widely used in this electrical vehicle, okay, for the what we call this bidirectional converter. And of course, it can be used as fun as like the Shinkansen train, even our LRT, they are power electronics. It's driven by power electronics. Okay, obviously, the space station, solar impulse, the plane that flies using solar and battery only, no fuel. Okay, or even submarine. When submarine submerge, right, they don't use diesel engine because diesel engine require oxygen and it will exhaust carbon monoxide. So when the submarine submerged, right, everything is powered by electricity. So that it's quiet, it does not emit any, if it has exhaust, like what happened? On the surface, you will see a lot of bubble, then submarines down there. Okay. So it can be, as advanced as all these kind of technologies. Now we look at the power converter anatomy. So the blocks just now we see, right? All these small block, right? Now we zoom in. Okay, we zoom in into the blocks. You will see this. Okay, power source input. Your load is output. Okay, of course your load can be source, like you charge a battery. It can be a source. And then you have three things inside. One is converter topologies. What is converter topology? Topologies is the way how you wire, okay, the circuit or the transistor together. We call topologies. Very important in your exam, I will ask this question. Please draw the topology of so and so converter. Okay, it's very, very important because it lays the foundation of the power converter. And then we will look into switching device. Switching device is a transistor, diode, which form the topologies. Okay, so what types of diode you use or MOSFET, okay, will actually affect the performance of your converter. And lastly, control strategy. Okay, you all study control engineering already, right? Or control system, right? That is, you will see the application here. You all study PID, right? Wow, 1/S+1, right? And shit, what is that, right? But you can score full mark in your exam paper. I'm going to tell you what you see in all these funny number, okay, can be represented by power electronics. Okay, don't expect me to teach the basic of control system, but you will see, at least I will guarantee you, will see the application. I will show you how to simulate it and how to tune it. I think the most challenge of PID controller is what? To find the number of PI and D, right? Right, to get it right? That is the most challenge, because until today, there is no one method say, or use my method, I guarantee you tune. No, it really depends on your application. And it really depends on your experience. If you're dealing with this converter for many times, you look at the converter, the number automatically built out, or P is equal to this, I is equal to this, then pop, okay? So that is also what I want you all to do during the class for the hands-on. Okay, now we look at the converter topologies. Okay, there are many different topologies. Okay, I just list a few. Each topology has its own names. It can be called chopper, buck, boost, flyback, interleaf, half bridge, full bridge, three-phase bridge, neutral point clamp, dual active bridge, and so forth. These are what we call the topologies. All right. Okay, switching device. Like I mentioned, switching device is diode, thyristor, MOSFET, and IGBT. These are the four main components you're going to use for power electronics. And you can see in this graph, you will notice that thyristor can go to very high power, right? And up to 1 gigawatt, mostly used for the transmission line. Okay, the 250 kV and so forth. But its frequency of operation is very low. See, 100 hertz. And then you can see that BJT, IGBT, MOSFET, they operate at different range. All right, so when you want to design a converter, right, you have to know which are the correct switching device to choose. And then, of course, the last two here, SiC and GaN, GaN, okay, or SiC, silicon carbide. These are the latest material that used in the transistor. The latest, up to today, commercially you already can get, but it's damn expensive. Okay, but you can see that it can go way higher frequency and sit in between, okay, IGBT and MOSFET. Now, I believe you all will heard what we call fast charger right now, right? 35 watt, wow, charging your phone 80% in 30 minutes. This kind of tech night, right? Very true. How they achieve it? They're using GaN. Okay, they're using GaN with a very high switching frequencies, okay, to achieve this. So notice that next time you buy charger, if they label using GaN, high speed charger, okay, then you know that. And all this is just a graph of the, now basically nowadays it's only 3 components, 3 material, silicon, SEI, and GaN, okay? So this is where their applications, you can see, GaN is mostly at the, low end, like, your charger, your TV, right? Okay, and SiC is in between here, the application. Silicon, okay, can go all the way here. So that is the application range, okay? Now we already talked about topologies, we talked about switching device. Now lastly is the control strategy. Okay, so as we know that control, we use a lot of PID. But in power electronics, right, we only use P and I, we don't use D. We only use P and I, so we call it PI controller. And we have another type of controller called PR controller. Okay, proportional resonant. We have constant voltage, constant current control, active reactive power control, okay, instantaneous PQ. We have the synchronized reference frame control, all sorts of different methods of control. Okay, that makes the converter possible. Okay, and then the power electronic converter performance indicator. When you make a converter, how do you know that how good is your converter, right? Now, firstly is power conversion efficiency. Of course, there is theoretically no way to achieve 100%. Okay, there are always some energy losses. But if you can nowadays achieve more than 90% is already norm. Okay, that means you have 100 watt in. Your output after conversion, you should have at least 90 watt and above. So we call the efficiency 90%. Okay. And also another measurement is the power density. Now, power density is the size of your converter. The size of the converter, okay, is the power density. X, Y, Z, the volume, okay, is the power output divided by volume. That is the power density. That actually tells us that how come our charger becomes smaller and smaller, right? So the power density is improving. You see, in the old day, EV is not possible. It's because of the converter, it's too big. The motor is there, you put a converter, the car full already. Okay, So now the thing becomes smaller, smaller, smaller. The power setting becomes better, better, better. Everything is now possible for the EV. Okay. Of course, power density is a bit hard to achieve at our level. In other words, student project level. Okay. But efficiency, we still can achieve at student, what we call level. Okay, now we come to look at the power electronic tools, software tools. Okay. These are the world top power electronic tools, okay, used to design, analyze power electronic converter. Now, of course, MATLAB is one of them. Another one is called Plex. Another one called PSIM. And another one called Typhoon HIL. And the last one is PSCAD. These are the top 5, okay, power electronics software tools. We are going to use MATLAB as a mainstream. Okay, I will choose either one of them for you all to learn through your assignment. All right. Okay, so now about installation. UCSI has subscribed a campus-wide license for this MATLAB. So as long as you use your student ID, okay, cannot use Gmail or Hotmail. You go to this website, you type your university, UCSI University, you type your email, you submit, it will tell you whether your email is eligible to install full license MATLAB or not. Okay, by theory, you should okay. So what you need to do is that, okay, first do a check first. After that, go to the website. There are 3 videos. It will teach you how to install full MATLAB into your computer. Full license, full MATLAB, official one, not the crack one. Okay. Please get it done before the next class. Okay, because you need this to actually, when I teach, right, for the hands-on purposes. And then, okay, bear in mind that you must have enough hard disk. Because to download, I think is around how many gig already? 8 gig, if I'm not mistaken. And then you download, okay, installation. If your hard disk got a lot of space, just close your eye and install all. Okay, it will eat up you 16 gig of hard disk. But if you like say, oh shit, not enough space, right? Then you have to choose, right? Choose what you want to install. Okay, maybe I will show you what to install. Okay. I have prepared a lots of power electronic model, okay, for you all to do in the class. All right. Okay, the online site, you all have any questions?
So far, okay, sir.
Oh, good. Okay. For mechatronics student, I will encourage you install all. Because inside got a lot of robotics, toolbox, all this, it will be very useful to you all. Unless your hard disk really just left like 10 gig, 20 gig of storage lah. But normally close your eye, install all, okay? Because UCSI already pay for it. It's part of your fees, and you don't want to take the full package, man. Right? So I also want to utilize this as much as possible. Because in the old days, right, when UCSI want to use this MATLAB, we cannot like now you can install all, you select just a few. Okay. But now it's better already. You pay one fees, lump sum, okay, for every year, you can download everything. You guys log in, log out, remember, for the team for attendance record. Wow. MATLAB is very, what we call this CPU intensive software. Okay. Of course, it says 4 gig of RAM can use, but advisable to go up to 8 gig. Because it eat up a lot of RAM for MATLAB. It eat up a lot of resources. If you look at the task manager, then you will know already. CPU, not really, unless you're running a very complicated, what we call this a model, like a FYP level, it may take hours to run. Okay, but for all this power electronic, right, I will try to simplify it as simple as possible. Now you can see that it ate up my memory up to 92%. Once I started MATLAB. Before I start MATLAB, it's only ate like 47% of my RAM. I already use up to, I already installed 8 gig of RAM. CPU is really depend on how complex is your model, so it doesn't really matter that much. Especially when you first open MATLAB and first run, it takes a longer time. But once you run for the first time, the rest of the MATLAB will be very fast already. Because it need to preload, the data already stored in the cache memory. Okay, obviously you need to install the entire Simulink. Okay, that is the most important one. And you need to install control system. Because you want to tune the PID, you need control system, okay? And then you need to install, okay. You need to install Simscape. And inside Simscape, right, you can see there are electrical, these are the one we are going to use. Simscape electrical, so install the whole Simscape. And then, yeah, that's about it. You need to install this support package for Arduino. Okay. Because this is to teach you how to use Simulink, right, to program Arduino. Because Arduino, I know that you all need to write the code, right? And let's say I ask you to write PID controller. It's very hard, right? If I want you to write the Laplace transform. So MATLAB have this advantage. It will help you to compile the model, make it into code, and download into Arduino. So yeah, I think that's all. But like I say lah, if can install all lah. Otherwise, when you need it, you need to install again. Okay. Or hardware too weak, then you better get a computer that can support lah. But normal 4 gig should be able to work properly as well lah. It's just a little bit longer. Okay. Okay, up to this point, any questions?
No question.
Okay, thank you. And then physical class, any questions? Okay, no. All right, yes. Okay. I'm still in the midst of thinking lah, but basically the assignment, you need to use MATLAB for sure. And then I will ask you to use another software to do the same model. So you compare the difference. All right, so at the same time, the purpose of doing this is that I want you all to really understand the principle instead of the software. A lot of our students have this problem. When they learn MATLAB, right? When they go out, especially when they want to do their postgraduate research, then the supervisor asks him to use another software. They seems like they don't know at all. They say, oh, I only know MATLAB. They are so stick to MATLAB. So it's wrong, okay? Because if you know the principle, you change whatever platform, you still can work, you know. Important, it's just like programming language. You know the basic fundamental of coding, right? I change Python, I change Visual Basic, I change Java. You should be able to program the thing. The logic is the same. What you need to learn is only the syntax and the UI difference. You know, where is the play button, right? Hiding somewhere else. So that is the purpose. And of course, the other one is the hardware lah. Okay, so I think most probably we won't go for hardware, but I appreciate if you guys really take effort to do it, you can come to me, I will let you know. Okay, what to do lah. Okay, yeah. So you can look at my slide set. It's already all I uploaded. Today is brief introduction, Power E, finished already, right? And the rest is 1, 2, 3, 4, 5 chapters. So each of them will take some time, okay? I try to cover as much as possible. Like I say, it's actually not possible to cover all converters, but at least you know the fundamental 4. The knowledge required to do the simulation and to build the model. I think our next class is in the morning, right? Wow, 8 o'clock. Challenging time, man. Oh, Thursday, 8 o'clock. Okay, so if no question, then we will end the class today. Okay, like I said, get your computer ready with MATLAB. I think the first class we are going to do already. Most probably the first class, you will do some simple model that I have done. Okay, and then you, like for example, if we look at this, Okay, like this one. Okay, this is the model I already done, no worry. What you all need to do is that you just go to this website, MathsWord. You can download it and run in your computer. If everything is installed okay, it should be run. I will show you, it will be run on my computer here. And then after that, I will continue to push it. Then I think this one I will ask you all to do. And so forth. There are many models I add in already. Okay. Okay. So for those online, make sure you all also install MATLAB. Okay. So that you know when you are done, screen capture and put it in the chat box. Okay, Zun Guan, I think it's up to you, lor. If you don't want to learn, I cannot force you. Okay, just get yourself ready on this lah. Any more questions? Okay, so if there is no question, we will end the class today. All right.